Welcome to monochemistry. Today we're going to look at determining whether or not a reaction is a redox reaction. Redox reaction is a special type of reaction that involves two things. It involves a reduction. Let's pick a different color that we can actually see. It involves a reduction and an oxidation. Right? And realistically, if you have one of those, you're going to have the other. There's no such thing as a reaction that only has one. They complement each other, so you have to have both. If you're going to have one, you have to have the other. Now, in order to determine if it's a redox reaction, we have to determine the oxidation numbers of the elements in each of the compounds in the equation. So we're going to have to use the rules that we've learned, and there's four really that you have to remember. The first one is that any element is always going to have an oxidation number of 0. The second one is that all group 1 metals take a +1 oxidation state. The third one is all group 2 metals always take a +2 oxidation state. The fourth, and I guess there are 5, I should have said 5. The fourth one is that oxygen usually takes a -2 oxidation state, and that hydrogen usually takes a +1 oxidation state. Those are the 5 basic rules you have to know. Okay? And we're basically just going to apply those rules as we go through. Let's move on. Okay, so if we're trying to figure out if this reaction is a redox reaction, then what we're going to do is we're going to go ahead and assign oxidation numbers. The more you practice, the better you'll get at this. But just really quickly, look at this one. I know that magnesium is an element, so I'm going to go ahead and assign it an oxidation number of 0, and same with zinc. Very straightforward. Most other elements, unless otherwise stated, are going to take on the charges that they would normally take if they were forming ions. Okay, there are some exceptions to that, but generally speaking, that's how they're going to work. So in this case, if I look on my periodic table, I see Cl is in group 17, and group 17 elements generally take on a -1. And that's no different here. Magnesium, we already said that group 2 elements always take a +2, so magnesium has to be a +2. Zinc, hopefully you remember this, but maybe you don't. If you don't, make sure you try to do it. Zinc is always going to be a +2. It's one of the ones that it's one of those transition metals that always takes on a +2. Okay, so there, I've done what I needed to do. Maybe I did it a little bit faster than you would have, but you need to practice to make sure you can get that fast too. Okay, so step 2 is to determine if there are any changes to the oxidation numbers of the elements in the equation. Now, if you think about it, we started with magnesium, and magnesium turned into Mg2+, or +2. And we also started with zinc. And zinc had a +2 to start with, and at the end, zinc had a 0. So, determine if there are any changes in the oxidation numbers of the elements in the equation. Yes, there are. Sometimes the answer will be no. Step 3, if there are any changes to the oxidation numbers of the elements, then it is a redox reaction. Yes. Okay, so if you go through every one of the elements in the equation, and there are no changes to the oxidation numbers of any of the elements, then guess what? It's not a redox reaction. The only type of reaction that you can just look at and know whether or not it's a redox reaction, I shouldn't say that. The one that you can look at and tell for sure that it's not a redox reaction is a double displacement reaction. Those are never, ever redox reactions. Okay, so here's the thing. Practice, 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 practice. Those 5 rules that I talked about here. Those are the only ones you really need to know. I guess a sixth rule would be most elements take the charge that they would normally take as ions. That would be a sixth rule. Okay? Practice, practice, practice. You'll get good at this. And that, in a nutshell, is how you determine whether or not a reaction is a redox reaction.